Hi, have a pleasant day, my dearest graded students. How are you? Are you doing fine? I hope that you are doing well and active today. Are you feeling excited? You should be, as we learn and discover together about science adventure. I am Gregory T. Remedio, your science teacher. But before we dig into our lesson, let's widen our mind and make our brain active with this fun learning game called What Am I? Are you ready? The mechanics of this game is just to guess the following given picture. What's your guess for the first picture? Very good. That is an ice. How about the second one? Good. A dry ice. The third one is very good, a juice. How about the fourth one? Yes, the fourth one is an ice cube that melts. How about the fifth one? Very good, a frost that forms on the leaf. And the last picture is very good, a steam from the kettle that is boiling. How is our game? Did you guess all the pictures? Great! But before that, I have a question for you. First, what is necessary for a phase change to occur? Second, what are some real-life examples of phase change? And the last one is, what is the behavior of a substance during a phase change? Have you answered any of the questions? Wow, very good, class. What are the two words that are common among the questions? What's that again? Very good. So now, I welcome you all to the world of chemistry, specifically phase change and their behavior or molecular arrangement that pertains thereunto. But before I discuss to you on what are the behavior of molecules related to phase change, let's have a recapitulation of our last lesson. First one, heat, which is a form of energy, is either absorbed or released by a substance during a phase change. Last lesson, we tackled that during phase change, there must be an energy that can be released or absorbed for each state of matter for them to change. Then, the temperature needed to change solid to liquid is 0 degrees Celsius. The transformation from one state to another is called change of phase or the phase change. And lastly, change of phase occurs when energy changes. Class to our last lesson, let's now discuss phase changes in terms of their arrangement of molecules and behavior with the three states of matter. First, solids. What are solids? Solid has different shape and volume, meaning they have regular shape and can occupy any space of a container. Second, most dense phase, because they are incompressible since all their molecules are tight and compacted and have a strong connection or intermolecular forces. Their particles vibrate in fixed position. They have crystalline lattice structure and most attraction between particles. On the other hand, liquid has definite volume. Why? Because they can occupy any space of a container, but their shape is indefinite or no different shape, since they follow the shape of a container. If it is round, they can suddenly in a round shape, or if it is square, they can be in a square shape depending upon the shape of a container. And the same with solid, they are hard to compress or incompressible. And their particles slide past each other. Why? Because their molecules are slightly tight. That's why they have enough space to slide past each other. And their forces of attraction between particles still high. But gas or gases has no different shape or volume. They expand to fill the container. They have the lowest density because the molecular behavior is high or the molecules can freely move. That's why the density of gases depends on pressure or depending upon the pressure exerted by a human. And they have a little attraction between particles. Why? Because of their arrangement, in terms of their molecules. Because if their molecules are far away from each other, it has a tendency to attract in a minute way or in a little attraction. This is the diagram about changes in phase. This picture class represents the state or phase of matter as it changes. The solid, liquid, and gas. And when the solid phase turns into a liquid phase, that is the process called melting or liquefaction. And when the liquid phase turns into a gaseous phase, that is evaporation or vaporization. And when the gaseous phase turns into a liquid phase, that is condensation. And when the liquid phase becomes a solid, that is freezing or solidification. Sublimation and deposition is the two types of special phase because it skips a little or it skips a bit in a particular phase that is liquid. Why? Because when we say sublimation, that is when solid bypasses the liquid phase, then turns or transforms into gas, while deposition is when the gaseous phase bypasses and turns into solid, and that resulted to deposition. But did you know, class, that matter behaves like human? Matter also excites or feels active when there is more energy, but slows down or feels weak when energy is released, and that is the reason why phase changes occur. There are two types of chemical change that happen when they undergo alteration, and these are the exothermic change and endothermic change. Exothermic change, class, is when energy is released or exceeds, or the phase changes occur when the energy is released, and that is by the presence of exothermic change. To simplify it, let's put it in a symbol. A plus B, and the product is C plus D. The product or the resulting product occurs because we try to release an energy. But when we say endothermic change, that is when energy is absorbed or entered. That is A plus B, and the energy that is absorbed with the A plus B resulting to another phase change C and the D. In the thermic change, energy is absorbed and overcomes attractive forces between particles, and it occurs in a liquefaction or melting and evaporation or vaporization. This picture class shows that if we increase the heat energy of their temperature, the molecules started to be active over time, resulting them to melt and evaporate, which means that temperature and time is directly proportional. When we say directly proportional, that is when we try to increase the time to change the phase 1 into phase 2, their temperature as well goes increasing. And when it happens, energy is trying to be absorbed by the solid phase to become liquid, and the liquid phase to the gas phase, and overcomes in attractive forces between each particles. In exothermic, as particles come closer together, energy is released, and it occurs into a gas to liquid phase, or that is condensation, and the liquid to solid phase, that is phasing or solidification. This picture shows that when energy is released by a gaseous phase and a liquid phase, the molecules started to slow down over time, resulting them to undergo condensation and freezing, which means the temperature and time is directly proportional. Again, class, as I mentioned earlier, direct proportional means that when temperature is increasing, the time as well is increasing. And when these two, the temperature and time goes high, the molecule of gas changes, or it slows down, or it becomes weak over time, resulting them to undergo a condensation and freezing. This diagram shows the disparity or difference between endothermic and exothermic change. Class, when we say endothermic change, that is a change when the energy is being absorbed by a certain state or a certain phase. That is represented by a blue arrow that goes up. As what you've seen, class, when the solid phase absorbs the heat energy, it become warm, and then it melts, and then turns into liquid. And when the liquid phase absorbs the heat energy, it will undergo warm and boils and turns into gas. But when the blue arrow goes down, that is an exothermic change, or from the word ex, exit, or when the energy is being released by a certain phase or a state. For example, when the gas phase releases its energy all throughout, it cools, and suddenly it condenses, then it turns into liquid. Very good. And the liquid phase releases its energy, it will become cool, and it freezes, and it will become solid. On the other hand, class, if enough energy is added to a solid of another kind of matter or different substance, it can bypass the liquid state and become a gas. This process is called the sublimation. What is sublimation? Sublimation is directly from the solid phase to the gas phase, and it happens or occurs with substances with weak intermolecular forces of attraction. The example for these are dry ice, that is carbon dioxide, so to speak, which is a gas and turns into solid, and the disappearance of naphthalene bonds. you remove enough energy from a gas, its molecules will slow down enough to form into a solid. This process is called deposition. What is deposition? Deposition directly from the gas phase to the solid phase and the opposite of the sublimation. It happens when you remove enough energy from a gas. And the example of the deposition is when the frost is formed on the leaf or on the ground and the snow. By the way, class, have you ever wondered on what is the difference between a snow and a frost? Okay, I will tell you the reason. When we say snow, class, it is produced or it is made because of the high energy in the atmosphere, while the frost is produced or happens because of the enough energy or high energy on the surface. Again, snow occur because of the high energy in the atmosphere in the Earth's surface, while frost is made because of the enough energy on the ground or on the surface. To summarize, class, or to tie a knot, the three states of matter, the solids, liquids, and gases differ because of the arrangement, motion of their particles, and their attraction between them. And the attractive forces between particles weaken as the temperature is increased because heating makes the atoms or molecules vibrate and move faster, like as liquids. And lastly, the addition of heat energy causes increase in kinetic energy or the motion or the moving of energy, the moving of molecules or the particles, and temperature. The removal of heat causes the opposite. Do you have any questions, class? Okay, since you don't have any questions, let's make it a day. Again, this is Gregory T. Remedio saying God goodbye and God bless, and enjoy science learning. You may now ask Dado.